All right, in this problem, you have this entire quantity taken to a power of 0. Okay, so you can treat this as your base. The entire quantity is your base. So any number, as long as it doesn't equal 0, taken to a power of 0 always has a value of 1. So the x not equaling -5 is what identifies that that base will not be a 0. So its value is 1. Now, here's probably the common mistake on this. And this is for all powers, or all these. If I say a binomial power, do you guys see what I'm talking about? You see why this term is a binomial? How many terms are there? This factor has 2 terms, so it's a binomial. Okay, this power of 0 does not, okay, so this is not true, even though this is the common mistake. You can't say that that's x to the 0 plus 5 to the 0, which is kind of the most common mistake in this problem, which would then be 1 plus 1 is equal to 2. Okay, this power of 0, when you think about it applying inside of a group, it applies only to factors or a product. Okay, it doesn't apply to a sum or difference, not things being added or subtracted. Since this binomial is being added, this power of 0 doesn't apply to each individually. It applies to the whole thing. And this also holds true, so when you guys start doing, here soon we'll get to this, but like if I say x plus 2 quantity squared, a lot of people are tempted to say, well, this is x squared plus 2 squared. But it's not. You can't just apply this power to each individual term of a sum. You have to think of it as those entire quantities. And so here's our first and our last are accounted for in what the common mistake is, but that misses out on these outer and inner products when you FOIL. And so again, we'll talk about that as we get to it. But just keep in mind, this power of 0 does not distribute. It simply applies to the whole quantity, or if that's a set of factors, it applies to each factor independently. Any other homework questions that you have from chapter or the 2.1 section? Connor?